Okay, class, today we're in lesson 6.4, Analyzing Graphs. Lesson 6.4, Analyzing Graphs. Please write down the section number and title as you head your notes. Write down the section number and title as you head your notes. Essential question: how can you describe a relationship given a graph and sketch a graph given a description? Explore Activity 1, Interpreting Graphs. A roller coaster park is open from May to October each year. The graph shows the number of park visitors over its season. Okay, now as you look at the graph, you'll notice that the y-axis is representing the number of visitors. So here, visitors start at 0 and it increases. Notice that the x-axis is representing time. So here's time 0, and then it increases as we go along. All right, let's get started learning how to interpret graphs. A. Segment 1 shows that the attendance during the opening weeks of the park season stayed constant. So segment 1, as you can see, is constant. So the number of visitors stayed the same as time increased. The number of visitors stayed the same as time increased. Describe what segment 2 shows. This is segment 2. As you can see, as time is going along, the amount of visitors is increasing. Now, how do we describe that? Well, you can say a steep upward slope shows that the attendance rises quickly. A steep upward slope shows that the attendance rises quickly. Based on the time frame, we're in B right now, based on the time frame, give a possible explanation for the change in attendance represented by segment 2. So in other words, what they want to know is, why do you think there's an increase in the number of visitors? Why do you think there's an increase in the number of visitors? Well, one possible explanation could be that the increase might coincide with summer break from school. So in other words, when the kids are off from school, you're going to see an increase in the number of visitors to the park. All right, let's take a look at segments at question C. Which segments of the graph show decreasing attendance? Give a possible explanation. So when you look at your graph up here, you'll notice that line 1 is constant. Segment 1 is constant. Segment 2 is increasing steeply. That is, it's increasing kind of fast over a short time period. Segment 3 is also increasing. It's also increasing, but over a longer time period. Now notice that segment 4, see, its line is going in this direction. That's a negative. That means that's a decrease. Segment 5 is also going in the negative direction. That's also an increase. So once again, constant, increase, increase, decrease, and decrease. So segments 4 and 5 will indicate a decrease in the number of park visitors. All right, and the reason for that is that the decrease might coincide with the end of summer break and when school starts again. Explain how the slope of each segment of the graph is related to whether attendance increases or decreases. Reflect. Explain how the slope of each segment of the graph is related to whether the attendance increases or decreases. So your conclusion there should have been, a positive slope shows that the attendance increases, and a negative slope shows that the attendance decreases. Explore Activity 2, Matching Graphs to Situations. Grace, Jet, and Mike are studying 100 words for a spelling bee. Grace started by learning how to spell many words each day, but then learned fewer and fewer words each day. Jet learned how to spell the same number of words each day. Mike started by learning how to spell only a few words each day, but then learned a greater number of words each day. All right, now try to match which graph goes with which person. Here, we can see that the words learned in A are constant. It's constantly increasing, and it's increasing by the same amount each day. So for me, that would be Jet. Jet learned how to spell the same number of words each day. All right, here we have someone that started out kind of slow, but they got to a point where they were increasing. Started out kind of slow, but got to a point where they were increasing. That might be Mike. Mike started by learning how to spell only a few words each day, but then learned a greater number of words each day. Here at C, this person started out learning quite a few words a day, right? But then slowed up and started going almost no words because the line is almost straight to where it's constant, see? Where it's constant, they're learning nothing new. Started out a lot, then they slowed down and are almost learning no additional new words each day. So that right there might be Grace. All right, so let's take a look and see what we have. All right, we have Jet for A, Mike for B, and Grace for C. Describe the progress represented by graph A. I've pretty much covered this already, but let's go through it again. Graph A shows a constant rate. This means the student learned how to spell the same number of words each day. That would be a constant each day, and it's increasing. B, describe the progress represented by graph B. Graph B begins with a shallow curve and gets steeper. This means the student learned a few words at first and then learned more at the end. So once again, very few words. See the y-axis? Those are the words. Very few words at the beginning, but as he went along, he learned more and more words that increased. C, describe the progress represented by graph C. Graph C begins with a steep curve and gets more shallow. This student learned many words at first and then learned fewer words at the end. So once again at C, they learned many words at first and then they tapered off to where they basically learned no additional words towards the end. D, determine which graph represents each student's study progress and write the student's name under the appropriate graphs. Okay, so after we would have gone through and did what we just did, then we would label each student, Jet, Mike, and Grace. You've probably already done that. What would it mean if one of the graphs slanted downward? What would it mean if one of the graphs slanted downward? You're going to reflect on this. What would it mean if one of the graphs slanted downward? In other words, instead of the graph going this way, the graph will end up going this way. That would be in a negative or decreasing direction. Here, the graph will be the person was learning, and then it went backwards, so to speak, right? So they were increasing, and then went in a negative direction, right? What would that mean? Well, that would mean that at one point the student knew how to spell the words, but somehow the student forgot how to spell the words that he or she had already learned. Tell whether each graph is linear or nonlinear and proportional or non-proportional. So this is like a review of a concept that we've already learned. Here, we can see that it's linear, and we know that it's proportional because it's going through 0. Here, we can see that it's nonlinear, and here we can see also that it is nonlinear. So once again, linear, nonlinear, nonlinear, proportional, non-proportional, and non-proportional. Explore activity 3. Sketching a graph for a situation. Mrs. Sutton provides free math tutoring to her students every day after school. No one comes to tutoring sessions during the first week of school. Over the next 2 weeks, use of the tutoring services gradually increases. A. Sketch a graph showing the number of students who use the tutoring services over the first 3 weeks of school. So we make our graph, students, and of course as it goes up, that means it's increasing. And time. Time is expressed in terms of weeks. So no one comes to tutoring sessions during the first week of school. So during that first week, the number of students is at 0. But over time, the number of students begin to increase. All right, so this is one version of how your graph can look. Mrs. Sutton's students are told that they will have a math test at the end of the 5th week of school. How do you think this will affect the number of students who come to tutoring? Sample answer. More students might come to tutoring before the test. After the test, the number might decrease. More students might come to tutoring before the test. After the test, the number might decrease. Part C. Consider your answer to be, sketch a graph showing the number of students who might use the tutoring services over the first 6 weeks of school. Consider your answer to be, sketch a graph showing the number of students who might use the tutoring service over the first 6 weeks of school. Once again, we have students, we have time, all right? And so here we go. At the beginning, once again, no students showed up, so that's 0. Over weeks between 1 all the way up to about week 5, begins to increase. We can see it's increasing. Then, after that test is over, we can see a real sharp decrease. A real sharp decrease. All right, so that's what it should look like. Okay, reflect. Question 3. If Mrs. Sutton offered bonus credit to students who come to tutoring, how might this affect the number of students? Sample answer. More students might come to tutoring. Question 4. How would your answer to question 3 affect the graph? Sample answer. The graph will shift upward because more students will participate. Overall, trends would stay the same. All right, this concludes our lesson for today. Let's go ahead and get to work. Okay, before beginning the lesson, let's just do one more problem for practice. Activity. Determine which of the graphs below, showing time and distance from the starting point, could represent a person taking a walk. Justify your answer. Determine which of the graphs below, showing time and distance from the starting point, could represent a person taking a walk. Justify your answer. In other words, if you pick graph 1, 2, or 3, explain. Another way to look at it is to simply explain all 3 graphs. Graphs 1, graphs 2, and graph 3. Okay, here's your conclusions. Graph 1 shows a change in distance with no change in time. The distance changed, but time stayed the same, represented by the vertical line. So it cannot be the answer. Graph 2 cannot be the answer as it shows different distances at the same point in time. Graph 3 could be a person walking to a destination. They're walking, staying there for a period of time, so they stay at the same distance for a while, and returning to the starting point with one more brief stop. So here they started going back, but you can see that by the decrease, and then they had a brief